Good day, everybody. How are you all doing? This is Dr. Nandi. Today we are going to talk about confidence interval for population proportion. So I'll share my screen with you. Formula for confidence interval for population proportion. Ever wondered how this formula was derived? I will show it to you in a short way. Okay. So I have done a bell-shaped distribution, which is the sampling distribution or probability distribution of p hat. P hat is sample proportion. So p hat is in decimal or in percentages, usually in decimal. Okay, so what proportion of the sample shows certain characteristic? For example, if I wanted to know in a class of 50 students, that is my sample size is 50, how many have a laptop computer? If it is 35 students says they have laptop computer, then my sample proportion is 35 out of 50 or 0.7. Okay, so p hat is in the horizontal axis, and in the vertical axis, we have relative frequency. This is a bell-shaped curve, so the left half is equal to the right half. Okay, at the center where the peak is the highest, this is the position of the mean. The mean of the distribution of p hat is shown by mu p hat, and it is equal to small p without a hat, which is population proportion. And the standard deviation of this distribution is shown by sigma p hat, which is square root of p times 1 minus p divided by n. Now C is the center, point A is on the left of point C on the horizontal axis. Point A is minus Z alpha by 2 multiplied by sigma p hat below the mean C. It's below because it's on the left of the mean. And the Z alpha by 2, the standard normal value is negative because it's on the left of the mean. So similarly, point B, which is on the right of the mean C on the right hand side or the right side of the distribution, is Z alpha by 2 times sigma p hat above the mean C. So area under the normal curve to the left of A in the left tail is alpha by 2. And area under the normal curve to the in the right tail is also alpha by 2. Okay. So area in the center of the curve is 1 minus alpha. Alpha is the level of significance. What is level of significance? It is the maximum probability of rejecting null hypothesis when it is true, that is making a wrong decision. And 1 minus alpha is equal to C. C is the level of confidence. So with 1 minus alpha percent or C% level of confidence, we can state that the sample proportion P hat will lie between P hat, between P minus Z alpha by 2 sigma P hat on the left boundary, and the right boundary is P plus Z alpha by 2 sigma P hat. Why is this notation? Because we know the center is P, and if we go on the left of the center, we get to point A, which is Z alpha by minus Z alpha by 2 sigma P hat below P. So it is therefore the boundary A, the lower boundary is P minus Z alpha by 2 sigma P hat when we start from the center. On the right, point B is Z alpha by 2 times sigma P hat above the mean. So the boundary is center population proportion plus Z alpha by 2 sigma P hat. Now we will subtract P from all the sides, from the three sides. And in the left, we will get minus Z alpha by 2 sigma P hat less than P hat minus P less than Z alpha by 2 P hat. P cancels in the left boundary and in the right boundary. Now we will subtract P hat from all sides. So what will happen to the left boundary? We will get minus P hat minus Z alpha by 2 multiplied by sigma P hat less than minus P less than minus P hat plus Z alpha by 2 times sigma P hat. Now we will divide all the three sides by minus 1. If we divide by minus 1, this also will change or flip the direction of inequality. For example, less than will become greater than. So when we divide by minus 1, the minus P hat becomes P hat, the minus Z alpha by 2 becomes plus Z alpha by 2 sigma P hat. This is the lower boundary. It was initially the lower boundary. Now the less than sign has become greater than P, and that is greater than Again, dividing by -1, p hat becomes p hat, minus p hat becomes p hat, minus z alpha by 2 sigma p hat. So it seems like in this inequality, p hat plus z alpha by 2 times sigma p hat is the highest value. So it should be the right boundary or the upper boundary for the population proportion. And the lowest value is p hat minus z alpha by 2 sigma p hat, which is the lower boundary for p. So this is the formula for the confidence interval for the population proportion p. We do not know exactly population proportion, but we can at least find the lower boundary and the upper boundary within which the population proportion will fall with C level or 1 minus alpha level of confidence. So I will stop here today. If you have any question, please write me a comment. And if you like the video, please hit the like mark, and you also please subscribe to my channel by hitting the red subscribe button at the bottom right corner of the screen. If you have any question, write me an email, and I'll see you next time when I get back with another problem, another solution. Take care. Have a nice day.